Hello everybody, we're in KubeCon 2023 Amsterdam. I am Venkat Ramakrishnan. I am with Portworx by Pure Storage. I run products and engineering for Portworx. What barriers do customers face related to data storage while dealing with Kubernetes, while kind of moving to Kubernetes, right? It's a great question. It's something that I want to, kind of like talk through for our users here and customers and community as well. Overall, if you look at the storage for containers or Kubernetes, you need to rethink how storage is done for Kubernetes or containers. Essentially, Kubernetes is a highly opinionated orchestrator, so you could deploy an app. Kubernetes can deploy an app anywhere in a node or in a cluster and reschedule it anywhere else in the same cluster, depending on resource availability, how the CPU is utilized, how much memory pressure is there, and other application characteristics, and even I/O characteristics. So we need to, when it comes to doing storage for Kubernetes, the storage needs to be application aware and infrastructure agnostic, and should be able to handle any application anywhere. So when users move from their typical machine-centric apps and move them to an app-centric cloud-native application format, what they generally run into is their storage paradigms that they're used to in the past, where it was pretty machine-centric, pretty static, no longer work in a very dynamic world of Kubernetes. Now, Kubernetes delivers a lot of automation, takes out a lot of pain in managing applications in a large scale. At the same time, it also requires a certain set of new ways of doing how storage is managed. For example, a container can mount and unmount a volume anytime, and many applications can mount the same volume across a lot of different nodes. And you may need to be able to move applications from one cluster to another cluster for tiering the app or getting better performance, or even taking your application closer to the customer to like a edge cluster or everything, and your storage needs to be able to handle all of that. Plus, your storage needs to be completely secure, so you can host different kinds of applications and different applications with different security requirements in the same cluster. So end-to-end security is extremely important, and those kind of requirements need to be met when customers move their applications from a VM or a bare metal directly into Kubernetes and containers. So these are the few things that you need to keep in mind as you move from into containers, into Kubernetes, and run your apps at scale. So stateful and stateless apps are kind of like, it's used a lot generally when it comes to what kind of apps run in a major category of apps that run in a Kubernetes cluster. It's an interesting way to look at apps. Absolutely, there are some apps that are truly stateless, where they're kind of reading from an object store, an S3 bucket, and a few objects, and then render them. But in reality, most of the commercial apps, most of the mission critical apps are stateful. And what we mean by stateful is there is user data to be managed, there is configuration data to be managed, there is a lot of user data or machine data that is coming in that needs to be analyzed, it needs to be ingested somewhere, that needs to be rendered somewhere else, and even rendered for reporting, or even making changes into it, doing some analytics, writing the results, and redoing the analytics again. So there's a lot of such write, read, repeated write kind of operations that happen on the data. Those are kind of like typically what we call as the stateful apps. And if you look at the world around us, there is no app that is built, no true mission critical app that has been built without state. Even the so-called stateless app has to read the data from somewhere where it has been already pre-written for it. And in some cases, the stateless apps are event processing engines, which are just streaming data, analyzing them, and writing it back into some other output, and don't store anything. And you see many of them, especially in, for example, in serverless environments, or in event processing engines, where you see them running kind of what we call as stateless apps. But anything that is a lot more mission critical, that handles user data, that delivers a true end user application, has to be stateful. Otherwise it's you're not delivering the user experience, the customer experience you want. And most of the modern apps are built anyway with a ton of analytics that is built in, again, which needs a lot of state, because analytics requires you to build, you need to have history and logs and need to kind of have enough heuristics to be able to make decisions. So there's a lot of state involved with that as well. Optimizing cloud costs. What is the trend in here, and what are the customers looking for? First of all, this is a very important conversation, especially in today's economic climate. Every organization out there is trying to run a set of apps or their entire applications in the cloud, and as we all know, when not managed right, cloud costs can spiral out of control. And customers are typically looking to see how they can run their applications, how they can reduce the size of the instances they are running, reduce the memory footprint if they have to, and even looking for ability to save storage costs. I mean, this storage costs can come, for example, in a cloud block volume capacity storage like EBS, or it could even come in the form of how do you, if you use a managed service like a database like RDS, how do you store your database tables and how much you get charged for it. So, and then there's a ton of other costs that if you look at a cloud bill, you see that there's a ton of other costs you're getting charged. So end of the day, what customers are looking for, and the customers we work with, they want to have a lot of control over their applications and data and their configurations, and need true transparency in their pricing and their cost management. So especially with Kubernetes, now customers have the ability to run their apps at scale, similar to how they would run a cloud service, but can pretty much be managed in their own Kubernetes clusters. So what it gives them is total cost transparency and total cost control and control of the data. For example, if you take Portworx and run Portworx data services, and you can, we support about 11 data services with our Portworx data services. You could point your Kubernetes cluster to the PDS service, and you can single click and deploy, for example, Postgres as a service on any cloud. So now you have visibility into which Kubernetes cluster it is running, where the data is running, how much underlying storage it is utilizing, and what is your cost associated with it. So when we talk to customers and we kind of show them that's the level of transparency they get, there's a ton of interest, and those are the kind of solutions customers are looking for, especially going in today's economic climate. How do you do what you do at scale, but still have a lot of visibility into costs, and how to control them so you can turn off data services or shut down instances, or free up storage space that you're not using anymore, and then only pay for what you're using and scaling for, and then and pay less when you don't need that scale. And that's delivered through Kubernetes and Portworx data services today. So disaster recovery is another very important requirement when it comes to running applications at scale in production in Kubernetes. And Portworx was one of the very first vendors to ship true DR, disaster recovery, for Kubernetes applications. We did this in about 2018 or something, where we shipped both synchronous and asynchronous DR. And why it is important, before we go into what the DR does in Portworx and how we do it, why is DR important? What we have seen, and we have seen this trend from even 2018, 2019 timeframe, is as customers embrace Kubernetes and containers, and they could be on-prem because they had to build cloud-like services in the data center, or even on the cloud because they kind of became a matured or transition from being a data centers centric company to a cloud company. We saw our customers move their containerized apps into the cloud. And what happened is, when they brought in more and more mission critical apps, business continuity became a very important question. It even became a serious regulatory and compliance question, where a lot of our customers were asked, okay, but what happens if your data center has an outage? Or what happens if your cloud has an outage? Or what happens if your Kubernetes API server goes down? How will you recover, right? So the moment people started betting their businesses on Kubernetes, disaster recovery became table stakes. And we introduced Metro DR for zero RPO DR. That means you can literally instantaneous failover, and then across like a metro link, or like a low latency link that can span 2 cities or even like 2 states if you have enough speed. And then we also introduced async DR that you can replicate across a WAN. For example, you can have a cluster in US West and another cluster in US East, and you can asynchronously replicate. And a lot of our customers, especially in the banking and financials, use this feature heavily. And we announced a couple of months ago a new capability called near sync DR, where essentially you get like a tens of seconds RPO, and your data centers or cloud regions can be apart like 300, 400 miles, for example, adjacent states, even at about 25 millisecond latency. And this is extremely critical for high-speed transactions like high-speed trading, on stock trading and financial transactions, because these kind of customers have to have compliance around being able to switch over and fail over to an adjacent data center with very little data lag, so they can continue their trading operations. So we introduced near sync DR for that. So we have like 3 different kinds of DR capabilities: synchronous DR, asynchronous DR, and near sync DR, to kind of meet all of our customers' business continuity requirements. Data security is another very important topic when it comes to running multi-tenant applications in your Kubernetes platform. What do I mean by multi-tenancy? What we see is that in a typical Kubernetes cluster, what our customers do is that our customers are generally platform teams, and our platform teams support their customers, which are application teams. And in many cases, our platform teams are onboarding multiple different application teams into the same platform and scale it, because it is too much to manage hundreds of Kubernetes clusters. It's easier to manage a few Kubernetes clusters with thousands of nodes sometimes, or even with many hundred nodes. And when you bring those different application teams into these Kubernetes clusters, you want to make sure the data is properly fenced and they are not stepping over each other's data, and data visibility is controlled, and the application owners have control on who gets to access what kind of data. So what Portworx does with our end-to-end PX security capability, we can enable an application to only mount a volume if it has an access token to it. So applications are namespace scoped, and then you have Portworx does volume scoping with our access tokens. So it creates a very structured, layered RBAC based on how applications can access the data. Plus, Portworx supports data at rest and data in flight encryption, and customers can bring their own keys. They can rotate their keys if they want. So it gives them end-to-end data security, where every application owner can literally control access to their data, and also can control who gets to read the data based on the security keys that they bring in. So the platform teams can literally onboard hundreds of application teams into their platforms without ever having to worry about the data leakage and data visibility, like where some teams get to see access data that they're not supposed to see. And that's how Portworx enables end-to-end data security and access control for mission-critical applications in large-scale Kubernetes clusters. HA is a very important capability that Portworx brings to the table, and it has been one of the most important capabilities of our product right from the beginning. Right when we looked at kind of bringing enterprise class data storage and data management capabilities to Kubernetes, the very first capability our customers were demanding was, hey, what happens if a Kubernetes node outage happens? What happens if one of my EC2 instances gets taken down? What happens if my server restarts? How do you ensure my applications get rescheduled and have immediate availability to the data? So Portworx supports different kinds of replications, up to 3 replicas per volume, and all of these replication capabilities are available per volume. So you can literally choose how many replicas your application needs, and when you have more than one replica, like for example, you have 2 or 3 replicas, when one of those nodes with a replica dies, automatically the applications are rescheduled to the nodes where the other replicas reside, and they mount the volume from those nodes. So it gives you a lot of data locality, but also instantaneous failover for these applications with 0 application downtime. Now, why is it important? Imagine you're running a Postgres database. Imagine you're running a MySQL database, and you're dealing with hundreds of thousands of transactions per second, and you're onboarding a large enterprise application. And in a large-scale cluster, especially hundreds of nodes, a node dying, a server restarting, is not uncommon. And when those kind of events happen, or like when you have to go patch operating systems because there's a new security update that needs to be applied where the servers need to be restarted. Portworx ensures in those kind of events, the applications never see that there is actually an underlying infrastructure upgrade or infrastructure restart or infrastructure event that is happening. So automatically the applications continue to run with the highest availability. So that is the level of SLA guarantee we deliver for these kind of mission critical apps on any Kubernetes cluster and with the Portworx application and high availability capabilities. Well, what is in store for the future? It's always a great question. I can look at my crystal ball and tell you, a few things that are going to happen for storage for Kubernetes and generally data in Kubernetes, right? And mostly. One of the promises of Kubernetes is self-service. It means your developers, your application teams don't have to rely on the infrastructure owners to continue to run their applications. It delivers the promise of DevOps really in the hands of developers, in the hands of application owners. It liberates the platform teams from having to manage and deal with hundreds of thousands of different kinds of apps and still deliver the level of SLA their organizations demand, deliver the governance, deliver the security, deliver the compliance, everything that the organization needs, but enable the applications team to continue to operate relatively independently without kind of waiting for an infrastructure team or a platform team or waiting for tickets to be resolved. But what's going to happen in the future is that more and more capabilities are going to become self-service. Right? For example, we introduced Portworx data services. We support about 11 data services today. We're going to continue to expand the amount of the level of data services we support, the number of data services we support. We're looking to add more capabilities into orchestrating an entire application stack. So, and how do you manage that? How a developer can simply deploy an entire application stack, the stateful stack, without having to talk to a data services team, a DBA team, a platform team, and bring their applications to any Kubernetes cluster. And we're looking at also, how do you ensure you deliver a level of QoS to each application owner so you guarantee the level of their performance, you guarantee the I/O throughput they get, you guarantee the latency they want to get. And we're also looking at, how do you support higher performance? We introduced a new edition of Portworx called PX Fast, which delivers millions of IOPS, and we're continuing to drive more and more performance capabilities into the product. So we're delivering low latency apps, low latency performance for high performance apps or demanding apps, plus also let our platform team scale those apps in production and deliver it to a large number of users, eliminate noisy neighbors as these more and more workloads get packed into these containers, into the Kubernetes clusters. We're going to run into a lot of noisy neighbor scenarios where one application is going to step on another application and all of that. So we're building these guaranteed application performance engines so that delivers customers the level of performance they ask for, and instead of what they actually get from their deployments. We're also looking at driving more and more autonomous operations in a cluster. So the level of human intervention that is needed to manage a large-scale cluster, we're constantly driving that down to zero. So the cluster is constantly monitoring itself, learning from itself, and healing itself so it can autonomously scale, it can autonomously operate about 99.9% of the tasks that where a human intervention is needed. So there's a ton of those kind of capabilities. And we're also looking at how do you proactively support the application owners instead of reactively supporting them. That means delivering the right kind of observability, delivering the visibility that they need, and delivering the actions they need to take, and kind of do work with them kind of in a GitOps integrated manner so they kind of integrate seamlessly into their workflow. So we're delivering a lot of those automations as well as we go into the future. So there's a lot of exciting times ahead for storage in general and Kubernetes in particular, and there's a lot of different new innovations that's coming from across the community and from Portworx as well. And look forward to the future taking shape.